Donc bonjour à tous, merci d'être venus tous présents ici ce soir. We will switch in English because we have two international speakers tonight. Just for the introduction, just let me welcome everyone here and give a warm welcome to Serverless Days and thanks Serverless Days Paris for this remote session. And of course, the Paris Serverless Architecture Meetup also. And I'm the co-organizer of the Serverless Architecture Meetup. And we will also thanks every speaker and everyone here in this meetup. So this stream is live on YouTube. And if you got any questions on the two talks here tonight, you can ask questions in the chat of YouTube, and we will try to answer that at the end of each talk. So let me introduce you Ben Smith, which is a senior developer advocate at AWS, and he will speak about the new LAMP stack is serverless, with AWS Lambda, API gateways, MySQL, and PHP. So if you want to start, Ben, the live is yours.
Sure. Let me just go ahead and share my screen. Make sure you can all hear me okay. This one. We good? Thumbs up. We good? Thumbs up.
Good.
Yeah. Okay.
Yeah.
Cool.
Good.
Hi everyone.
Yeah.
Okay. My name is. Cool. Hi everyone. My name. And I'm going to talk to you for the next 30 minutes or so about the serverless LAMP stack, both the concept and the implementation of. I'm currently a senior developer advocate for AWS, specializing specifically in serverless. But prior to that, I was a PHP developer for something like 15 years. And over the most recent kind of 2 or 3 years or so, I came to discover this thing called and to show you how that's possible. So one of the reasons I initially started building serverless applications was because of some of the sort of inherent challenges with the traditional LAMP stack. And the main challenge that you always kind of come across is that scalability is an issue with LAMP in general. So by scalability, I mean an application that can handle highly variable levels of traffic. And PHP applications are often scaled horizontally like this. So you add more resources as web servers when needed. And this is managed often via a load balancer, which directs and requests to various web services, or various web servers, I should say. And each additional server brings additional overhead in the form of networking, administration or storage capacity, backup and restore systems. And if you're working in a large organization, you can also have admin issues trying to update asset management inventories. So as each server has to scale in this way, you also have new storage challenges that arise, as each has its own files and its own disk space and own file system, and that often requires developers to add a mechanism to handle user sessions. So using serverless technologies, a lot of these problems go away because scalability is managed for you as the developer. So if the traffic to your application surges, these services will scale automatically to meet that demand without having to deploy any additional services or any additional servers. And this allows applications to transition really quickly from prototype to production. So I mentioned that now is a really good time for PHP developers to have another look at serverless. And I want to just touch on why that is in terms of the last few years and the roadmap of releases at AWS. So back in 2014, AWS first launched Lambda, and this is a compute service that runs code in response to events automatically and manages all the resources for you. Then followed shortly after that, in July of 2015, they launched Amazon API Gateway. And this enabled developers to build secure and scalable APIs that can form the sort of front door to a variety of back-end architectures and services. Then in November of 2017, we launched Amazon Aurora Serverless. And this was a new configuration for RDS databases that allowed you to pay on a second-by-second basis. So this is moving RDS more into a serverless payment structure. Then in November of 2018 was a very significant release of Lambda layers and the custom runtime API. And this is what allowed developers to create their own custom runtime. And we'll dive into this in a bit more detail soon. Then in September of 2019, there was dramatic improvements to Lambda function startup performance for Lambdas needing access to a VPC. And this is significant because when you create a RDS database on Aurora, that's created inside a VPC, a virtual private cloud. And so you need your Lambda function to have a fast response time to be able to access that. And then more recently, in November of 2019, we launched Amazon RDS Proxy, which is a fully managed, highly available database proxy for RDS databases. And this makes applications super scalable and resilient when using RDS databases. So that's the sequence of events that's led up to this talk. And here is a serverless version of a LAMP stack. And we're going to step into each component of this now in a little bit of detail and then look at how we can create this. So the L stands for Lambda, and Lambda is very much serverless in that it fulfills these four kind of key tenets that we talk about sometimes at AWS, where the first is that there should be no infrastructure to provision or manage. So that means no servers to spin up and nothing to operate or patch, no physical or virtual container orchestration of any sort. The second is that your service or Lambda should and does scale automatically, and that's scaling by unit of consumption rather than by unit of server. Then there should be a pay for value billing model, and so you could call this pay for idle in that when your service is not being used or there's no request being driven to it, you're not paying for it. And the fourth kind of tenant is that it should have built-in availability and fault tolerance. So there's no need to architect for availability because that's baked into the service. So when we say serverless, we're talking about the removal of server operations. And that's an important distinction for our customers because it allows them to focus on building their application rather than spending time on the infrastructure that their application sits on. So Lambda sits at the center of a few kind of trends and terms that maybe some of you use. And Lambda is all of these things. It's event-driven compute, it's functions as a service, it's serverless functions as a service. Essentially what it does is it lets you run code without provisioning or managing servers, and you pay only for the compute time that you consume. So with Lambda, you can run code for virtually any type of application or back-end service without any administration. And Lambda itself doesn't just sit in a vacuum. It typically forms or is formed of two or three different components. So the first is the event source, and the event source can be a number of different things. It could be a change in data state from a database that your Lambda function is acting on. It can be a request from an HTTP endpoint, or it can be a change in resource state. So essentially, the event source is the thing that triggers your Lambda function to start executing code. The next component is the function itself. So this provides a curated runtime environment with various languages built in and supported natively. Some are listed here like Node.js and Python. And as I mentioned, with the runtime API, you're able to bring your own runtime to Lambda. That's where we'll bring PHP. The final component is the destination that your Lambda function sends its results to. And this can be really whatever your code needs to do. It depends on the business logic of your particular application. So moving from LAMP stack and from PHP into a Lambda world, there's some interesting things about a Lambda function which you need to kind of get your head around and take note of early on. The first is something called the handler. And the handler is the function inside your Lambda function that starts executing code. That's the start of your Lambda function execution. It's the thing that is invoked by the event source. And in this function is two kind of key arguments that are passed to it. The first is the event object. And this is a JSON object that holds information about the event that invoked the Lambda function to start running. The next object is the context object, and this contains information about the invocation itself, and this provides methods allowing you to interact with the runtime and the execution environment. You'll notice above the handler as well, there are the functions dependencies, and these can be config options or helper functions. And here's where you might initialize a database connection or any form of sort of static initialization. So it helps to think of the anatomy of a Lambda function as a kind of dartboard or a series of rings going from the outermost layer in. So first there's the Lambda compute substrate, and that's the underlying compute layer for Lambda. Next, there's the Lambda service itself, and this manages the scheduling and the organization of workloads across hundreds of thousands of customers. And both of these layers are completely invisible to the customer. They're managed entirely by AWS. Then a little further in, there's the execution environment, and this is customer specific and AWS account specific, and it's the secure space where the code is run. And in each execution environment, there's a language runtime, which is where your custom PHP runtime will sit. And within that is the handler function itself, which is the packaged up version of your code, which is unpacked and executed on invocation. So we'll come back to Lambda in a minute when we look at how to build a custom runtime. But next I want to move on to the A component, which is API Gateway. So APIs are the front door to your backend services. And at AWS, we have a service called Amazon API Gateway, which is a fully managed service that makes it easy to create and maintain and secure APIs at any scale. And these APIs can be used to access data and business logic or functionality from your backend services. Now, API Gateway itself is a really comprehensive service, but some kind of feature highlights would be that it's perfect for communicating with microservices. It has built-in protection from DDoS attacks and throttling for your backend. And you can configure to authenticate and authorize each API call in a number of different ways. So then the M is still MySQL, and that's MySQL running on Amazon Aurora using Amazon RDS Proxy. So Aurora is our cloud-native database service, and it's still our fastest growing service in AWS history. It provides high performance and availability for MySQL and PostgreSQL databases. And the underlying storage scales automatically to meet demand. It scales up to, and I have to read this, 64 tebibytes. I don't even know what a tebibyte is, but that sounds massive. A database instance is created inside a virtual private cloud, so that prevents public access to it. And in order to connect an Aurora database instance from a Lambda function, that function must also be configured to access that same VPC. And we now have a relatively new service called Amazon RDS Proxy, which was in preview until yesterday. So this went generally available just yesterday. And this is a DB proxy that lets you pull and share database connections for improved application scaling when using RDS or relational databases. So before RDS Proxy, a common problem that our customers would report was that they would experience database memory exhaustion. And this would happen when they have a number of connections to their RDS database. And those connections might surge as their requests to their database goes up and Lambda scales by these connections opening and closing at a high rate. And this would lead to slower queries or limited application scalability. But RDS Proxy is implemented to solve this problem. So it establishes a database connection pool that sits between your application and your relational database. And you're able to reuse connections in this pool. This protects the database against oversubscription without the memory and the CPU overhead of opening a new database connection each time. What's cool about this as well is that credentials for the database connection are stored securely in AWS Secrets Manager, and they're accessed via AWS Identity Access Management, or IAM role. So this enforces strong authentication requirements for the database without sort of costly migration effort for the database instances themselves. So this is a high-level illustration of the kind of token exchange that you can do to obtain a token to connect to your Aurora database. The connection is made from a Lambda function running PHP. The Lambda function connects to the database using RDS proxy, and the database credentials that RDS proxy uses are held in Secrets Manager and accessed via IAM authentication. Once you have that token, you can then use the same code to connect to your Aurora database as you would do normally, and I'll show you what that code looks like in a moment. So the core of this talk is about the P in the LAMP stack, which is still PHP, and this is PHP running on Lambda. So one of the sort of fundamental goals of Lambda is to make it easier for developers to build applications. And one of the ways we are able to do this is by managing the language runtime for our developers. There's a bunch of language runtimes natively supported, and these represent the majority of what our customers are writing applications in today. But sadly, you'll notice that PHP is not on this list. And I say sadly because PHP represents still almost 80% of the web today, at least 80% of the server-side languages that we know about. And PHP has some similar characteristics with serverless in that it's a stateless request-based language. So there's a whole generation of developers out there that understand how to code with a request-based mechanism. So how can you use PHP in Lambda? And the answer is to create a Lambda custom runtime. So you can do this for not just PHP, but any Linux compatible runtime. And you do this by using the HTTP runtime API. This is a codified, this has codified the runtime by using calling conventions and integration points that we'll have a look at in a second. And once you've built your custom runtime, you can publish it as a layer and distribute that out to your organization and reuse that in multiple Lambda functions. So you can select your custom runtime from within the console or using the API or an SDK or command line interface. And you select that to be the custom runtime for your Lambda function. Once you do that, you also need to provide to your Lambda function a file called a bootstrap. And this bootstrap file is really important because it's responsible for the communication between your code and the Lambda environment. So this is a kind of conceptual image of what this bootstrap file does. So it acts as a kind of bridge between the runtime HTTP API and the environment that needs to be executed. So the bootstrap file itself can be written in PHP, and it's responsible for a number of things. It needs to process events and find out which is the next invocation to run. It needs to initialize and invoke your function, and it handles the
Hello, this is Chris from the Serverless Days teams. It seems we have an issue with Ben connection. We will try to get him on board as soon as we can. Please stand by. Bonsoir à tous, Chris de l'organisation de Serverless. On a un petit problème avec la connexion de Ben. On essaie de le retrouver très très vite. Donc restez en ligne. On essaie de vous remettre le live dès que possible. N'hésitez pas, en attendant que l'on retrouve Ben, à poser vos questions directement dans la fenêtre de chat de YouTube à droite de la vidéo.
Hi everyone, I'm Guillaume, and I will be the speaker during the panel, and I will ask your question to both speakers. So don't hesitate if you want to ask us question. I will try to have question for both speakers to have something more like a discussion, something like that. So you will have both opinion. So it can be really cool. So don't hesitate. I see there is already two questions, so you can continue.
Did I drop off there?
Yes.
Hello, Am I
Hello
back?
again, Ben. Yeah, you're
Hey.
back.
Okay, is my screen still on?
Seems so, yeah.
Okay, I'll just carry on then.
Go ahead.
Okay, so here you can see I'm installing Composer, and then using Composer, I'm
sorry, Ben.
Yeah.
If you're sharing your terminal, we don't see your terminal.
Ah, okay. Let's try that again, shall we?
And Ben, you dropped just at the beginning of the explanation of the bootstrap.php file for the Lambda custom runtime API. If you can start back from that point, if it's okay for you.
Okay, you tell me which slide. That sounds like quite a way back.
Yeah.
Did you see this one?
Yeah, this one.
This one. Okay. This one.
Yep, at the beginning of this one.
Okay. So this is an illustration of how your Bootstrap file is communicating with the Lambda function. And the Bootstrap file is responsible for a number of different things. So it will manage the events and headers. It will initialize your Lambda function and invoke that function. And then it will handle the responses and the errors given back from the function. And then it will perform, or it needs to perform the cleanup as well. And there's a number of different environment variables that are available to your Bootstrap file to enable it to communicate with the Lambda function. So the three key ones are listed here. You have an environment variable which allows the Bootstrap to know the host and the port for the runtime API. You have an environment variable which holds the handler name, so it knows what to invoke on your Lambda function. And you have an environment variable that holds the directory that contains the function code. And so here is an example, a simple implementation of that Bootstrap file. I say simple because this Bootstrap doesn't have any error handling. But here you can see where I've used the environment variables to obtain information from the Lambda function. And here I'm using the runtime API to invoke the next function or to get the next invocation. And here I invoke the function and retrieve the response. And then I send that response back to the Lambda function. So you can see all of those components in action in this one small Bootstrap file. And then what I'm able to do is to publish that Bootstrap and that custom runtime together as a Lambda layer, and I can share that layer out across all my different functions. I only need to do this once, and I have then created a custom runtime environment. So you only need to know how the runtime API works to create your own custom runtime environment, or you can use an open source layer that's been created for you, and there's a number of these already available, which I'll point you to later on. So another question that we get is, if I want to use a certain version of PHP or a module or a package dependency, how can I do that with my custom runtime? And that's fairly straightforward. What you need to do is in your Amazon Linux environment, you compile your required version of PHP. So here I'm compiling version 7.3. Then I include any extensions I want with the configuration. So here I'm including MySQLi because that's what I want to use to connect to my MySQL database. And then I package the PHP binary and the Bootstrap file together into a file called runtime.zip. I then publish that as a layer called PHP example runtime. And then I add that layer to my function using a serverless framework or the console or SAM. I think this example is using SAM. So I can do a similar thing if I want to add package dependencies. So here I install Composer, and then I install the AWS SDK for PHP, or I require that using Composer. I then zip all of my packages up into a folder called vendor, or a file called vendor.zip, and I use the CLI to publish that into a layer. And so here's a screenshot from my Lambda function where I have two layers on my PHP Lambda function. The first layer is the example runtime, which holds all the Bootstrap information for my runtime API. And the second is the example vendor layer, which holds all the package dependencies. And here I'm using those two layers in a Lambda function. So first I import some items, some libraries from the SDK, and then I use them to connect to my Aurora database using RDS proxy. And these 12 or so lines of code is actually everything that's performing this token exchange that we looked at earlier to grab a connection from the pool of connections to connect to my MySQL database. So if you don't want to go through the rigmarole of creating your own custom runtime, you don't have to. There's some excellent options out there for you. And I think probably the best option for you getting started would be to use Breath, which is an open source production ready PHP runtime for AWS Lambda. It's got a really active community and it's got fantastic documentation as well. There's another layer which is widely used as well, which is offered by Stackery, and this is what launched with the custom runtime API as the PHP layer back at reInvent a couple of years ago. And all you need to do is grab the ARN or the ARN of the layer that you want to use, and then you can include that to your Lambda function, as you see here, by setting the runtime as provided and setting the layer ARN in your definition of your function. And you can find more layers with this link here, by the way, if you're interested in that. So coming back to our serverless LAMP architecture, this spells out LAMP nicely, but actually the order of requests is more like this. We would come in from API Gateway into Lambda, and then we use PHP to communicate with MySQL database. Now we know now that PHP is running on top of Lambda and that MySQL is running on Amazon Aurora. And this is all happening in the AWS cloud, and this is the direction of the request. We know that your RDS database is inside of VPC, and we know that the request is coming inbound from outside the cloud, and you would probably want to have something like a CDN to route those requests. And then you would serve the static assets from an Amazon S3 bucket, and this is what we'll look at next. You could also use AWS Amplify Console to set up a CI/CD deployment pipeline for your application as well. So one way that we see people using Lambda, that we see people using PHP with Lambda now is as a scalable web host. And serverless purists might not like this way of using Lambda, because essentially what you're doing is you're using a single Lambda function to host your entire application. But this is a good kind of middle ground for PHP developers that want to understand a little bit about how serverless and how Lambda works. Essentially, what you're doing is using API Gateway to route all requests directly to your Lambda function. And this is similar to how you might route requests to index.php in a MVC model. And you're able to do this by creating a couple of rules in your API Gateway config that catch all inbound requests and route them directly to your Lambda function. So here is a sort of comparison of how you would do this using an Apache config with HT access file versus using the SAM template, where you just set up two rules to route requests to Lambda. And this is a great way of getting started with serverless PHP, but there's a couple of things you should watch out for. Is that you don't want to serve static assets from your Lambda function in this way, because you pay for the time that your Lambda is running or your Lambda functions are running. So for any static assets, you would want to serve them directly from an S3 bucket. So that's things like images or JavaScript or CSS files. And you can do this by placing a service called Amazon CloudFront in front of API Gateway and in front of S3. And this then gives you the option to route requests from particular URLs to a static S3 bucket, and then dynamic requests can be all routed to a single Lambda function that contains all of your PHP code. An additional benefit of this is that you can use the CDN of Amazon CloudFront to cache, to create caching rules to bring some of those static assets closer to your users and further reduce latency. And using this kind of technique as Lambda as a kind of scalable web host with routing through Amazon API Gateway, you can build out PHP applications using Laravel and Symfony. And there's some great example use cases of how Bref enables you to do this. Another way, and this is the more kind of pure serverless way that you might move into with once you start using serverless technologies with PHP, is to use Lambda as functions for event-driven microservices. So in this technique, the front-end application will make requests to a resource that's generated by API Gateway, but that front-end application sits in your browser and runs in browser memory. So perhaps that's built in pure JavaScript, or that's raw HTML that's using Ajax to make requests to Amazon API Gateway. API Gateway then routes those requests, depending on the rules that you set up, to a specific Lambda function with a small amount of scope. And that Lambda function will perform some compute. It might use RDS proxy and to use the pool of connections to communicate to your MySQL database, and then return those results back along the request line back to the front end. What you can also do with this is use Lambda to send on to other downstream AWS services. So you can use EventBridge to have a serverless event bus to create a truly event-driven architecture. You can send things to an Amazon SQS queue. Maybe you want to use Lambda for with step functions to create serverless automation workflows. So this way you're creating a decoupled event-driven microservice, but you're still using PHP. Also, you might want to again use Amplify Console to deploy and host the front end, and you can configure that to work with, for example, a GitHub repository where on every commit to your repository, you're deploying to your environment. And all of these servers are serverless, so they scale automatically as needed in line with the demand on the application. So where do you start? I would say the best place to start for those of you wanting to use an open source PHP for Lambda would be Bref. It's very well documented, as I mentioned, and there's a great community behind that. In terms of AWS and serverless PHP, we have a code samples repository on GitHub that you can go to, and that contains examples on how to deploy some of the services I've mentioned in this talk. And that also has a community curated page of resources and articles and case studies from across the PHP serverless community, which is also a great place to read more information. So just to recap, the traditional LAMP stack doesn't scale so well, but with serverless technologies, developers, PHP developers can take advantage of all of those benefits of serverless. They can build scalable web applications without managing infrastructure. Imagine never having to do another Apache restart ever again. They can build decoupled microservices for their backend applications. They can use their Laravel or Symfony or their existing PHP frameworks. And this allows them to move from prototype to production really quickly because of the way that serverless services are able to scale. And you can do this with compiling your own custom runtime or by using an open source layer such as Bref or the Stackery layer. So you can build serverless applications with PHP, and I'm really interested to see what people start doing. Thank you for your time. If there's any questions I can't get to in this next Q&A, please reach out to me directly on Twitter. And if you do have 20 seconds to fill out, I think it's 2 questions on this feedback survey, then that helps us to improve this content for similar deliveries in the future. Okay, thanks very much for your time.
Thank you very much, Ben. Thank you so much for your talk. If you have 20 seconds, feel free to scan the QR code and to answer his survey. We have a few questions in the chat. We will be answer this question during the panel discussion after the second talk. Okay. And feel free to ask questions about this talk and the second one in the chat. And let me just introduce you, Marcia, from our AWS also, which is a developer advocate and the host of Fubar, a YouTube channel. And she will talk about how to migrate an existing application to serverless. So Marcia, if you want to talk, the live is yours.
Hello, everybody. I hope you are seeing my screen and my face and everything. Just yes. Tell me everything is fine, cool. So I will start. So my name is Marcia. I'm also a developer advocate for AWS, and I will talk a little bit on my experience and others people's experiences on migrating an existing application to serverless. So as I said, developer advocate, I've been doing serverless since 2016 in production. I will be talking a little bit about my story on serverless because it's my first migration on serverless, so it's part of the stories I want to tell you. And then I'm the host of a YouTube channel called Fubar. I have over 250 videos on serverless and cloud computing, so you might want to check it out and learn a lot of things there. And I'm very open on Twitter. I answer messages and comment on a lot of things, so you can follow me there. But that's about me. So this talk is going to be organized in kind of 3 main parts. The first one is a story that was not successful on the migration, then a little bit more successful story, and then some steps for you to migrate in a successful way that I have gathered through listening to customers and working in this space for some time. So the first story, first I will go through what is serverless, and I think already Ben gave an introduction to it, so I will go quite fast. But I want to address these points here that are about what serverless is as a methodology, as a mindset, that the idea is to minimize the heavy lifting, basically not reinventing the wheel and maximizing the value that we give to our customers, to our stakeholders. So that, I think, is the philosophy behind serverless. And we can hear from Jeremy Daly, that is a serverless hero, that he talks a lot about this, and this is his quote, and also from Jared Short, another influencer in the serverless space, that basically he says that if the platform has it, you instead of building, you use it, or if there's not in the platform, but the market has it, you buy it from there, and then even reconsider the requirements to try to adapt what it exists there, and if not, then you build it, but when you build it, you own it. And this is also represent the philosophy of serverless. So serverless, sure, it's these 4 tenets, but it's not only that, it's a mentality, it's a way of thinking on architecting your applications. Maybe your components are not 100% serverless yet because you cannot get there, but your mentality on how approaching the development of software is serverless. So at the end of the day, you will end up with a lot of little Lego pieces. It can be microservices, it can be platform components like Dynamo, Lambda, API gateways, and you have to put them together somehow into something like this. Well, this is an example, again, that another of our serverless heroes always put out, the Burning Moon or Yankee. And this is an architecture diagram of a serverless application. It may look very scary, but actually it's not, because every component is doing very little things and everything is very decoupled, and it's quite simple to follow. So it looks scary because it's just drawn all together in a screen, but when you start looking more in details, it's quite a normal application and it's quite easy to understand. But the idea that everything is made with these little Lego puzzles like the Lambdas, Dynamo, step functions, or whatever you are needing. So let's go to story number 1. That is the story, my first serverless project. It was 2016, and let's put it in perspective. Lambda was launched in 2014 in November. API Gateway was launched in July 2015. So basically, this was around June, May, somewhere there, 2016. Everything was very green out there. There was no material, no events, not really nothing about serverless. And I was working in this project that I was not in AWS, I was in some past life, working in a project that we were building a Netflix for cartoons. So we were showing cartoons to little kids that play them forever and ever. And instead of monetizing on subscriptions, we were monetizing on advertisement. When you're monetizing on advertisement, you need to be really mindful on how much your application costs. So it was the beginning of summer, and we get a message from the boss saying that our costs are too high. Our application was born maybe 4 or 5 years before that, and it was intended as a microservice application on Java. It was native to the cloud. We were running on AWS, but with the time, it turned to be like a little monolith. We have 4 or 5 little monoliths because we were too lazy to create new microservices, and we make very fat microservices, and then they stopped being microservices and became something else. And then we were very good backend developers. Well, very good. We end up with this mess, but we were quite good and we knew Java quite well. And when they told us that our application was very expensive, the first thing we were free developers, we went in and we tried to optimize the code, try to add caches in the server. We tried everything that we could to make the code cleaner and better. But we didn't know much about cloud and how cloud worked. So basically, all the changes we did not have an impact. So when we realized that nothing had worked of what we did, we started really looking on what the biggest problem was. And we realized that we needed to re-architect our whole application from bottom to top. We need to kind of migrate the whole application, not only the code, but the architecture. So we started learning about the cloud, and I was just getting started with serverless in my free time. I didn't have kids by then, so I had a lot of free time. And I told my boss, let's do it with serverless. Serverless has these cool things, and we can do it with serverless. And I think by that time, I might deploy like 4 Lambdas in my life. The serverless framework was out, but it was 0.5. There was not really a lot of mature tooling. So we went with this idea of going serverless. My boss, I think, was a little bit desperate and he wanted to get this problem solved. So he said yes. So we started coding and coding. And the first thing we did was build minimal viable products or prototypes, or how you like to call it, where we were basically validating that our idea that we could do it with serverless was real. So we started building, for example, one of our use cases, what we needed to migrate out from an database that was NoSQL, but we were hosting at home. We needed to replace that with Dynamo, so we were validating that we could do that. Then we were validating that we could use, by that time, step functions were not launched, so we have to create a very complex orchestration with Lambda and to produce some content, and we managed to validate that and things like that. So we created all this prototyping to validate all our assumptions, and then we were ready to get started. And we start coding. We start rewriting, and in the meantime, new features were added to the original service, and we keep on adding those features, so our scope keep growing, and 6 months pass. We're still writing code, 7 months, 8 months. In some point, we decided that we needed to go to production. So we did, and it was the longest time in our life. I think I cannot tell you how long it lasted. The whole going to production, in my head, it lasted for 1 year. I tell you, it didn't last for 1 year. Maybe it was a couple of weeks of pain, but it was so painful because we were putting into production things that we have not really tested in production, that we wrote 6 months ago, that we didn't have a whole, how I can say, we didn't have a proper monitoring tool in place because we were monitoring staging code that is not the same as production. And our service was very successful. It has, by that time that we were doing the migration, around 6 billion views. So it was very active. So when we start migrating the APIs, we start getting hit with a lot of traffic, and things start exploding in our head. By the end, with a lot of sweat and tears, we managed to migrate, but there was so much work to do late afterwards, and it was so painful, and we needed to really think about foundational parts of our application, like monitoring, to find a good monitoring strategy that we really didn't even thought at the beginning. So don't do this strategy. That's a bad idea. The story number 2 is a better story. It's from one of our customers, Comic Relief. That is a customer from the UK. That what they do is they take over the television for 1 day. They invite actors, singers, humorists. They do a show for 1 day, and they ask donations from the audience. So they usually have a very active service during the day, and they have peaks on donations, usually at prime time, where they may have 350 donations per second. Maybe in your head, it sounds 350 donations is not that much. 350 requests is like, but donations are not normal requests. Donations are requests that you cannot lose, that you cannot duplicate, that you need to track end to end, and they are very sensitive. If some donation gets lost in the way, maybe the person that made a donation will not make it again, and you will lose trust with your audience. So this is very important for them, that everything is safe. So prior to this event, before moving to serverless, they were stacking up servers and infrastructure, and they were preparing for weeks before the event to come to have the infrastructure in place in order to support this event. And the service was only available that day. So meaning that if somebody wants to donate today, they could not. So it was kind of a little bit annoying to build up everything for one day. It was complicated. So they started the migration the same time as we did in my previous story, 2016. This was the kind of architecture they have. They have a big monolith with Drupal. And then the part that we are interested is in this donate service. This donate service was its own service. And this was the one that was very, that we needed to treat with a lot of care. So they had it there, and they have to decide where they want to start migrating. So the objective for them was to migrate this donate service to something more scalable, maintainable. So what they could do is they can start with the least critical part of the system. I don't know, pick something that is not relevant and start learning. And then maybe at the end, you get to the donation, or then they can start with the donate service and get all the return on the investment very fast. Well, they didn't pick neither of these strategies. So they started by migrating the least important service, but then after a few iterations, they will migrate the donate service. So they get first by learning, and what they did is they start migrating this image gallery. I think it was something that nobody really cared a lot. They started with new technologies, React, serverless, and other cool stuff. And then when they gain experience with that, in 2018, they start migrating other services that maybe they were not that critical, again, to gain experience and feel confident, and also to build some kind of reutilizable components that they can take use later. So in 2019, they felt confident enough to migrate the donate service, and they did that. And this was the change that they were wanting for the rest. I don't know if they will ever migrate out of serverless, but at least the donate part, that it was the most complex part and the one that it was making everybody very anxious during the day of the event, they managed to migrate. This is the architecture they have. You can find the architecture description in that link. I will not go into details, but I can tell you that this architecture is very resilient. It has failovers everywhere, so if some donation gets lost in the way, it will be get by some other component and somebody will take it. So no donation gets lost when they are following this architecture. And this is something quite impressive. The yearly cost in 2015 before migrating was $84,000. So even though this was paid by partnerships and not from the donations, still for a company that was doing this type of thing, that they want all the money to donate to some charity, it's quite a lot of money just to run infrastructure. And then in 2019, after the migration, the whole year of their infrastructure was $5,400. And from that, only 92 is serverless. The rest is the Drupal and other stuff. And the cool thing is that they can have it open all the time. So if you want to go right now and donate, you can. They don't need to have the event running in order to take donations. And when they have the event running and take donations, they don't need to do any kind of 1 or 2 weeks of preparation, stacking servers in order to get everything ready. They just go and take the donations. So that's, I think, a really good way of doing a serverless migration, doing it in steps, in little steps, and start migrating for something that is not very critical until we get to the critical point, and maybe the rest we don't care on migrating and we don't do. So basically what they did is they followed a strangle pattern. They didn't have a monolith, they have already the servers, but at the end of the day, they started strangling and moving the servers, the services to a new way. You can also start with a monolith and start breaking the database into smaller pieces. And that's also how the strangler pattern works, until at the end of the day, you end up with the old services that you don't mind, that you might want to keep as they were, and the new services as well. So I will tell you how to migrate to serverless in 5 steps. very generic. And I will start with step 0, that is the foundational work, because why not? So the first things you need to do in order to get started. The first one is define what your microservices are. If you don't have microservices already, you might want to think what microservices you want, and for that you might want to use the reverse conway maneuver to organize your teams in order to represent the structure that you want to have in your application. Then you want to pick your developer tools, what frameworks you're using. It will be serverless framework, it will be CloudFormation, Terraform, CDK, I don't know which languages. Will you use PHP or will you use Node? What infrastructure as code from day 0? What kind of CI/CD pipeline you will have? Define one and start thinking about the different environments, dev, staging, production, where you're going to do your test. Start writing all those things out. And then think about monitoring and observability. Learn the tools, understand the alarms, find how you can understand anomaly detection, all these kind of things that maybe at the beginning it's kind of hard to get started and you might not get it right from the first moment. But then if you start building it from day 0, then when you are deploying to staging and then going little by little to production, you are testing these things and improving them along the way. So if you wait to set up your monitoring and observability until you deploy the big bang shaboom thing that you want to migrate out, then it might be too late and you might cry a lot like we did. So don't do that. Start from day 0 and think about what are all these things. And when you're picking your tools, you don't need to pick, oh, I will use serverless framework or SAM or for everything. You might have different tools and different languages for different parts of your application, but be cautious about it and think about it. The next step is to find the seams of the code. If you have a monolith and you want to break it up, you need to find where the application edge and where are the different bounded contexts. So now is the time to do that. And then start organizing the code inside the monolith and start breaking the data layer as well. When you have that, then you have the monolith ready to start moving it to serverless. And if you don't have a monolith, now you can start moving the code to serverless. But if you have a microservice, my recommendation is to think how big is your microservice. If it's a microservice that is not that micro, maybe you want to still breaking it into pieces. But well, when you start moving the code to serverless, I will give you a couple of tips how to design serverless applications. So the first thing you want to think about is logical microservices. So think about logical microservices as a set of Lambda functions, DynamoDB tables, API gateways, step functions, all these things that kind of make the application, all these Lego pieces. But we are talking about microservices, so not everything that you're migrating to is just a piece of your bounded context. And when I think about microservice, I like to think about small enough microservices. I like the definition that Sam Newman gave in one of his books, that it says that microservices should be able to be rewritten in 2 weeks. So think about that. How big is your microservice? How long it will take you to rewrite it? And then define the logical microservices with that thing in mind. My idea of logical microservices is that they can be deployed all together, but independently from other logical microservices. And also logical microservices share databases, and all that data is private to the microservice. So if somebody wants to access, they will have to go through the microservice. Then we have the concept of event-driven architectures. We want to decouple our microservices and our functions as much as we can. That will help us to do independent releases, to scale easier, and to have code that we can interchange and move around. So for example, in my first story, I told you that we started working on our orchestration service that was before step functions was born. And in the middle, we were working on that. Step functions were launched. And then because we were thinking on an architecture that was very decoupled, it was very easy to switch to step functions and to throw what we have built. So this adds a lot of power into your application. And you have multiple ways of decoupling your applications. You can use queues one-to-one, or you can use PubSub one-to-many, or Event Bridge many-to-many to add all these features of decoupling into your application. For example, if you want to connect microservices together, I like the idea of event routers and event buses, because then you don't need to register all your event producers to all your event consumers. You just have a new microservice, you put it there, you create some rules, and voila, it works. So these event buses or event routers are a great way to decouple your microservices in a macro level. But also you want to orchestrate your functions inside your workflows, because sometimes you have workflows where, I don't know, you are the typical example doing a thumbnail where you have to go through multiple steps and you want to have functions that are small enough. So in order to do that, you can use the step functions, for example, or some other workflow machine. I like this rule of thumb that YankQ has. That is, you will orchestrate within your bounded context, or meaning your logical microservice, and you will choreography between bounded context, meaning your microservices. So inside your microservices, you will use step functions, but when it comes to your microservices, you will use event bus. Then replace what you can with managed services. And this is a very important part if you are going to serverless. You don't want to reinvent the wheel. Do you have authentication in your application? Can you replace it with Cognito, Auth0, or some other managed service? Do it. Do you have an analytics pipeline there? Can you replace it with some existing component from the platform? And things like that. Start thinking about what you can do. You have a GraphQL server. Do you want to maintain it, or you can use AppSync? So start thinking about pieces of your application that are not really bringing value to you, that you just build them because you have to, but they are not valuable for your business purpose, and replace them with managed services. So then we go back to steps. Now we have some steps to move the code. Now we want to break the database. And when I mean to break the database, I mean if you have a monolith, you might have a very fat MySQL database, but also if you already have microservices and you are creating a new serverless microservice, you might want to rethink the database, because we are very used to use MySQL, and MySQL is great, but it's maybe not the most performant format for very scalable serverless applications. It depends on your use case, but analyze your use case and think about if your application will need to scale to some numbers that database might not hold, or if you can just change it into files or even into NoSQL. That's a good exercise, and this is the right moment to do. In most of the cases, MySQL or SQL databases will work fine, but in others, it might worth the migration. And the fifth step, the last step, is to move the APIs to the new backend. And here we want to point the customer's request from the old endpoints to the new endpoints without needing to change in the client. And for that, we can use a load balancer. And in load balancer, we have these weighted targets. And I think that's something I would have loved to have when I was doing my migration. Meaning that, for example, you can have 90% of your traffic to go to the old backend and 10% of your traffic to go to the new backend. You can test it, you can see if it works, and if it does, then you can migrate all your traffic. And that's something very powerful with the application load balancer that you can do right now. So I think I'm around time. So these are the steps. Do your foundational work. Invest time there on creating everything good from the beginning, but don't be too conscious. It will change over time, but invest the time at the beginning to be conscious of what you're doing. And if you have a monolith in premise or somewhere else, move it to the cloud where you're going to do the serverless migration, because it will help you later on in the steps. Then if you have a monolith, find the bounded context and start breaking that and organizing the code inside the monolith, and then start moving the code to serverless if you have a monolith or if you have already microservices. Then start breaking the database and rethinking if relational databases are the way to go for you, or you can take advantage of NoSQL or even files to do the job. Then move the APIs to the new backend by using some kind of targeted weighted load balancers, where you can move the traffic in a more scalable way, in a more like in steps, not all at once, and then repeat from 5 to 7 until you think you're done and you have moved your critical workloads to serverless. And that's it. Again, here is my contact details, so I will stay now for the panel, but if you have any other questions, I will be very happy to take them later on. That's it. Thank you.
Thank you very much, Marcia. Just to remind you, if you have some questions, feel free to ask them in the chat, and we will now go on the panel discussion. Let me just introduce you Adrien Blin, which is my co-organizer of the meetup, the Paris Serverless Architecture Meetup. And Adrien, if you want to give some word. Adrien, are you here? Okay, so Adrien is not here, or he can't. We can't hear you, Adrien. Maybe you're on mute. But okay, so maybe we can go with Guillaume now for the panel discussion.
Okay, thank you. So yeah, as I talked during Bern losses, so we'll do a panel discussion with both speakers. The goal is to have more view about your question, not only one opinion, one answer, but maybe more like a panel. So we had the first question, and it was during the Ben talk about the price difference between traditional infrastructure and an infrastructure with serverless. Marcia, you talk about it. You have an example of a great use of serverless to improve price. Is it always the case, or do you have some cases where serverless can be with a more price, or I don't know if it's always cheaper to use serverless?
Well, no, it depends on how you architect your application. In our case, it was cheaper because we tried to understand and to take advantage as much as we could from the cloud economics. So trying to take advantage of the edge and the cloud front and all these parts of the cloud that end up being cheaper. And we really thought about costs. But if you do serverless wrong, it can be more expensive. There is no right answer to say yes, it's cheaper, or I don't know what Ben thinks, but if
yeah, I would say it depends a lot on the nature of the workload that your application needs to handle. So if you have sort of spiky traffic, then probably a serverless way to handle that would be good, because it will scale for you automatically. Whereas if you have something that's maybe needs sorts of long-running synchronous workloads, then maybe Lambda isn't the best answer for you. So it depends a lot on what kind of traffic or workload that you need to build for.
Okay, and you talk about the goal of scalability and to use serverless. This can be price. Do you see another good way to use serverless, or there is something really good? Maybe about coding, about I don't know, about management, something like that. I don't know.
I mean, another benefit of serverless.
Yeah, another benefit. Yeah.
Oh, absolutely. Yeah. I mean, there's numerous benefits. There's a number of different talks that drill into these things in detail, but things like security. So when you're building event-driven microservices, you have kind of less surface area for your application, less exposure, and you're able to build each function with a much smaller scope and to define a very defined security around each function. So that's another great additional benefit. Also, you have things like the fact that your infrastructure is managed for you. So that's not necessarily directly related to scalability, but it's a whole sort of weight off the developer's mind, where you won't ever have to log into a Linux environment again and run something. As a developer, I'm terrible at stuff like that. So that's a big relief, and it makes developing serverless applications much more enjoyable, because all you have to do is link things together and write code every now and then. It's a much more enjoyable way of building an application, I think.
I will say that the cost of ownership is one of the main benefits of serverless. You don't own almost anything. And even you can build applications where you are not even writing any code. That is like you can do API gateway against Dynamo with AppSync, and there is nothing that you write yourself. It's all generated by you, and still is a very serverless application, but you don't own that. So I think applications with zero code are the best applications. You don't have to maintain. So trying to simplify as much as possible and focus on the business is, at least for me, one of the main benefits of serverless.
Marcia, you're talking about writing zero code as much as possible thanks to the serverless service offered. There is one service that has been recently released by AWS called Honeycode, which offers
but I'm
zero
talking
code.
about zero code in the sense of like you can connect directly API gateway to Dynamo, and well, you might need to write a little bit of velocity template, but it's not like you have to write a Lambda function or anything. Or you can even use AppSync and Amplify, for example, and use the CLI of Amplify, to generate all the backend for you. And you don't write any code. You only type in the CLI, Amplify, add API, and that's all you need. And then Amplify will build the schema for you, the resolvers for you, the Dynamo for you, all the CloudFormation you need. So that's my no code. It's not Honeycode, that is a different way, but this is just removing as much work as you can from the developers and the system creators to not need to maintain anything.
There was also another question about the preferred runtime to be used inside serverless. So Ben, you talk about PHP, and you said that it wasn't a language inside serverless or Lambda at first. What is the preferred language runtime to be used? Is there one or not?
So no, there's no kind of official recommended runtime to use with Lambda. We see that Node is the runtime that most of our customers, or the majority of our customers that use Lambda, are using it in Node. I think it's followed closely or followed by Python next. But Lambda is designed very much to be agnostic to the runtime environment. So theoretically, you could have development teams running their microservices in entirely different languages, and as long as they have a contract that agrees what that service does, it shouldn't matter. So that's another kind of hidden benefit of serverless and of Lambda that we don't really talk about much.
Yeah, the other day I was chatting with a person that had built a custom runtime in COBOL for Lambda. So.
And can you just is it a good idea to use COBOL?
I don't think so, but it's possible, and that's kind of at the end of the day, Lambda is running on a virtual machine, so you can compile as Ben showed whatever you want. But there are some languages, in my opinion, that will perform better in Lambda, like Node, Python, Go, because of the nature of the language. But I don't think there is a preferred language or recommended at all by AWS. It's a machine. You can do whatever you want with it and embrace the language that you are using.
And is there any time cost when using custom layers rather than using the provided layers? Do you have to wait a bit longer for your Lambda environment to start up, or do you have anything similar?
No, I don't think there is. No, there shouldn't be. In fact, I think, isn't it Ruby that uses the custom runtime API? It launched with that at least anyway. So there shouldn't be a performance hit. There will be stuff documented on that as well where you can check. But to my knowledge, I don't think it affects the performance using your own Bootstrap file.
Marcia, you talk about using serverless to just cut a big monolith. Someone asked a question if we can use some big framework also with serverless, or do we only have to do it for microservices or scripts, little scripts, or can we use a bigger framework? Is it a good idea or not, even in PHP for Ben after?
I didn't understand the question at the beginning.
The question is that can we use serverless for big framework? For big framework, we are talking about Laravel or stuff like that. Can we put some monolith inside a serverless application, I don't know, something really big, or do we have to cut it inside small pieces?
Well, I think now with the support of EFS, maybe you can put whatever you want. I don't know. Maybe Ben can elaborate more on that, but I think it's a matter of the loading time. If you have a very big piece of software, it will take a little longer to start your function, and there is some limits on the size on how big your deployment packages can be. But I would prefer to go with smaller components. It doesn't need to be like one small thing, little tiny thing. It can be something more big, but not to have a whole application. In my head, you're kind of losing some of the benefits of serverless, of having these decoupled systems that can collaborate in like event-driven way, and you can replace them easily, and you don't need to maintain a lot of it. But if that's the option, and there is many production services that are running like express application in one Lambda function, and it works.
Yeah, could I just add to that yeah, it's not the kind of serverless purest way to create one massive Lambda function that hosts your entire application. But there's lots of customers doing this very successfully. And if you check out the Bref custom runtime that I mentioned in that talk, there's, I think, some great case studies on customers that are doing this using Bref and using Symfony and Laravel. And it might not be the most efficient way to use these services, but it's quite a good gateway into understanding the concepts of serverless, and you still get some of the benefits of doing it whilst using your favorite framework. So it's like a nice middle ground. Ultimately, you want to be able to move to more of an event-driven architecture, though.
Okay, because we lose Adrien, we don't hear you, Adrien. So sorry, I will take another question. Ben, you talked about LAMP. So LAMP as it was to refer to Linux, Apache, MySQL, and PHP. So you transform it to Lambda, etc. But you transform something called a stack, because Linux was the beginning of the stack, and there was a lot of application, and it was mainly on the same node. And you transform it to something like a workflow. So there was something that put it, but inside the stream. Is it just like a transformation, just like we see inside DevOps or all the philosophy? We are cutting all the big silo with something else, or I don't know. I see something that kind of similar with similarities. I don't know if you agree with it.
Sorry, say that again. If we're doing something like DevOps.
You transform something like a stack into something on the same node, and you transform something to workflows and it's kind of similar. You are transforming all the stuff.
I see what you mean. Yes,
from horizontal to vertical, something like that.
I would say you've read too much into how I've drawn it. Maybe that's all. Could just as easily be vertical. But I understand what you're saying, because what I'm trying to represent there is the flow of the requests from each service. So I understand why you say that sort of conceptual jump to a workflow. But what I'm trying to do is take the idea of a web server and map that onto how you can use API Gateway and Lambda as a sort of scalable web host to recreate that functionality of a web server.
Okay, I'm not sure. I don't know if you are familiar to DevOps, and if it's something you are using it outside the culture. Can we use serverless in more efficient way to build some team as a DevOps or with this culture? It can be something you see on inside your experience.
Yeah, serverless is perfect for DevOps culture, and it's totally integrated in so many of, at least in the AWS tooling and in third-party toolings for building your continuous delivery. You can hook it in multiple places, even to to improve your, if you don't have a serverless application, you have a normal traditional application, you still can hook Lambdas into your continuous delivery to make it more efficient and to validate things and even to run tests and to automate a lot of the process. So definitely serverless is a great tool for that. And I have, I don't know how much content on my YouTube channel on how to do DevOps with serverless, because it's one of the topics I really enjoy. So
I've got a question, Marcia, about what you just said about serverless and DevOps. There is a new trend today that is no-ops. So serverless is often associated with no-ops movement. Do you think that serverless will be part of the no-ops movement, or do you think that?
No.
Yeah.
I think that's a marketing word, like serverless. There are servers in serverless and there are ops in no ops. I think the idea in the no ops movement is that there is no infrastructure to manage, but there is still a lot of configuration to manage. And in order to do a proper big serverless deployment of, sure, if you have a small company with few business logic, you can have no operations person, and there are many customers don't have. And you don't need, because there is so much automation in place that you don't need an operations person per se. But the bigger your application grows and the more complex and the more teams and the more people, you will need operations people, because you need the expertise on how to build the CI/CD pipeline, on how to manage the teams, on how to manage your AWS accounts. You might have 20 million of accounts and you might need to put that security, and you need still the knowledge. So I will not say that it's a no ops. Maybe in a small startup with 2 developers, well, no, there's no infrastructure to manage. But when it gets complicated, you need, like you still need a DBA, even if you're doing Dynamo. Like there is still like databases to be designed and to think about. So no.
So this is not the end of the ops team
no,
per se.
They will not go and patch Linux services anymore, but they might spend a lot of time configuring security and permissions in AWS accounts and creating ways to automate as much as possible the deployments and the management of different configuration files on. There's so many things that needs to be orchestrated, even if you're doing serverless.
Yeah, so it's a different kind of work ops have to do.
Exactly.
Yeah, cool.
We don't have any more question in chat. Maybe I have another one. Ben, you talk about some problem with DB, etc. Do you see another problem, or your customer have a problem you don't talk about, or maybe just like technical problem, or maybe an organizational problem? I don't know. Something you see really often.
No other problems.
No problems. Okay.
Yeah, so I think maybe the next kind of challenge in serverless is that of monitoring and observability. So you have all of these now kind of disparate services that are connected to form potentially many different microservices that then comprise your application. So now the next challenge is perhaps how do you keep track of the monitoring and the performance and the observability of all of those services? And AWS has tools for that, and lots of partners have tools for that. But I see that as being a really important part of this next kind of evolution of serverless.
Okay, thank you. I don't know if anyone has another question, or if you want to have a last word about serverless and to say all the good things you are thinking about.
I do have one at the moment. So after listening to both of your talk, Marcia and Ben, especially Marcia, at the end you say if you want to migrate your application from a legacy infrastructure to a new world serverless architecture, the easiest way to do so is to find the theme and to start taking part of your application and put it into a serverless architecture. After what you said, Ben, that you can put a whole framework directly within a single Lambda to be executed as an architecture, as a serverless architecture. Another way of migrating an infrastructure, a legacy infrastructure towards serverless would be just to use something like Bref and put your whole Symfony application running on your old OVH instance and put it directly within the code. Would this be a viable option as to start doing serverless, or do you think it's dead end?
Well, I think what you need to think is what is the problem that you're trying to migrate from, and not migrate just to go to a cool technology. So that sometimes as developers, we tend to be beautified when new technologies. Containers came, let's use containers. Serverless came, let's migrate to serverless. So think about what is the real problems that you're trying to migrate from, and then try to think if just moving your whatever stack into one function will help you out. And if it does, then that's good for you. And maybe it doesn't, so you might need to re-architect your application.
Yeah, and I would perhaps add to that I wouldn't suggest that trying to dump your legacy Symfony or Laravel application into Bref is maybe the easiest way to start at all. Rather to look at perhaps building your next Laravel or Symfony application using Bref might be an easier way in. I imagine you'd get into all sorts of new problems that you haven't had the experience to go through if you try to put your entire legacy application into one Lambda function. So that's not what I'm advocating people go ahead and try when we hang up the call.
So not recommended.
Not at first.
Okay.
So thank you both of you. I think we are done. Yeah, I think we get all the message from the chat. So really, thank you for your talk. It was really cool to have some information, technical information from you, Ben, and all your experience, Marcia. It was really refreshing. Really, thank you, thank you. Thank you, all of you, Adrien, even if we don't hear you, Laurent, and all the Frederic and all the other person from the organization. It was really cool to have you. And so if you want to give you some feedback, you will have a feedback form, and so we can improve all this talk. We will have some other events, so keep in touch on meetup pages. So meetup page, so you know it. There will be some events in French also, if you prefer French. So maybe not for you, Marcia and Ben, but there is some people here that want it in French. So thank you, Christopher. Also, we don't leave you back for all this broadcast. So yeah, thank you.
Cool.